Hello everyone, welcome back. Today we are going to be doing chemistry. This is the multiple choice extended version. Today I'll be doing the variant number 1 version. So I recently did a variant 2 version. So this time I'm going to do a variant 1 version. And this is the recent paper, May-June 2023. So let's get started. Question 1. The diagram shows the result of dropping a purple crystal into water. So this purple crystal into water, this purple crystal is most likely going to be potassium manganate. So, which processes takes place in the experiment? Well, we can see that the purple crystal has dissolved into the purple solution. So dissolving is one of the factors. We can see it also diffuses in the solution equally so that the whole solution is equally purple. However, it is not a chemical reaction. Why is this? Because a chemical reaction, remember, a chemical reaction is where two reactants or one or more reactants, or basically a reactant turns into a product. In this case, the reactants is the water and the purple crystal. If you react them together, you essentially dissolve the purple crystal, but it is essentially still the same purple crystal, but just in a different physical state. It is basically just in solution, so if you remove the solvent, which is water in this case, you will get the original one, which is purple crystal, and therefore it is not a chemical reaction, so D is most likely the answer. Question number 2. Which rows about elements, mixtures, and compounds is correct? A metallic element, we have to know, is basically made of metal. A non-metallic element, basically non-metals, right? The non-metals can be found in the right side of the periodic table, and metallic element can be found at the left side of the periodic table. You must know that by heart as well. You can notice a trend. A mixture is something that you can separate. You can separate the mixture again. So we can say a mixture is basically an alloy in this case. So an alloy is basically a mixture of metals, and you have to know the two alloys, which is brass, right? Brass and bronze. You have to know those two because the syllabus says so. So next, compound. A compound is basically a group of atoms, right, that is bonded together. It's called a compound. So metallic element, this has to be copper. Non-metallic element, this has to be sulfur. A mixture could only be brass because brass is, an alloy. Brass is made out of 70% copper and 30% zinc. So the compound is going to be methane because it is made up of carbon atoms and hydrogen atoms. So C is the correct answer. Question number 3. The atomic structures of 4 particles W, X, Y, and Z are shown. Which particles are isotope of the same element? Remember, isotope is basically the same number of same number of proton, but different amount of a different mass number or different nucleon number. It's the same thing. Basically, they have different number of neutrons. So the electrons should also be the same because the protons are the same. So we can see that W and X has different protons, so they're definitely not the isotopes of each other. We can see that X and Z have the same proton number of 3. W and Y has the same proton number of 2. So W and Y, X and Z could be a pair, but we have to further look at if they are really isotopes or not. So the difference in between them is the amount of neutrons. If the neutrons are the same, this means they are not isotopes, they are basically the same element or the same isotope of an element. So you see in here, X has a neutron number of 2, Z has the exact number of neutrons, so this is basically the same element. So we can check the other pair, which is Y and W. In Y and W, you can see that the neutron numbers are different. In Y and W, you can see that the neutron numbers are different, but the proton numbers are the same. This means that they are isotopes of each other, so B is the correct answer. Question number 4. Which statement explains why isotopes of the same element have the same chemical properties? Now this is because they have the same number of outer shell electrons, and you have to know that because electrons are basically the entity or the subatomic particle that gives the chemical or the element the chemical properties, reaction, similarities between them, so A is most likely the answer. Question 5. Nitrogen forms a nitride ion with the formula N3-. Which particle does not have the same electronic configuration as the nitride ion? So remember this, notice that this is not nitrogen atoms or nitrogen molecules that we are talking about. If we're talking about the nitrogen molecule, we are going to write, because it is in group 5, it has a proton number of 7, we can write the electronic configuration as 2.5. But in this case, it has gained 3 electrons. We are writing N3- electronic configuration. So this is going to be 2.7, 2.8. Sorry, so it's going to gain 3 electrons, right? So 5 plus 3 is going to be 2.8. So it's going to have the same electronic configuration as a noble gas. Now let's look at Al3+. Al3+ is going to have Al, when we write Al, it is going to be 2.8.3, because it has lose 3 electrons, because it is 3+, it has lost 3 electrons, it is going to be 2.8. Now this 2.8 has the same electronic configuration as the nitride ion. Now let's look at sodium. Sodium, we usually write it 2.8.1, because it has a +1 charge. We know that it loses 1 electron. That 1 electron is being transferred into another atom, and therefore it's going to have electronic configuration which is the same as the nitride ion. For the oxygen ion as well, this goes the same way. When we write oxygen, we write the electronic configuration as 2.6, because oxygen is in group 6. And then we see 2-, this means it has gained 2 electrons, so 6 plus 2 is 2.8. So O2- electronic configuration is the same as the nitride ion. Now let's look at chloride ion. So the answer has to be B, but let's see why it is not the same. So when we write chlorine is basically 17, so we are going to write it 2.8.7. Now if we write the chloride ion, we can see that there is a negative charge, so it has gained 1 electron, so 7 plus 1, the outer shell has to be, you have to add the extra electron to the outer shell, so 2.8.8. Now this does not have the same electronic structure as the nitride ion, so this is the wrong option, so we have to choose question number B for the answer. Question number 6. Which rules describes the formation of single covalent bonds in methane? So the single covalent bonds are basically a pair of electrons being shared together in the methane molecule. So the atoms share a pair of electrons, they are not transferred to each other. This is an ionic. A and B are covalent. Both atoms gain a noble gas electronic structure. Both atoms have the same number of electrons in the outer shell. Now when the covalent bond, the main thing about covalent bond that you will learn in this IGCSE level is that the covalent bonds will always bond so that it will gain a noble gas electronic configuration. In other words, the outer shell electrons are full. So the answer for the question number 6 is A. Question 7. Which formula is an empirical formula? An empirical formula is basically the simplest or simplest ratio, right? Simplest ratio formula, basically. Empirical formula, that's what it stands for. And for here, you can see that these, the ones that I have underlined here, this is the molecular structure, because you can see how the group are composed of. You can see the atoms, carbon atoms, 3 carbon atoms, 7 hydrogen atoms, and their functional group. For number D, you can see that this is in an ambiguous structure. So this is basically an ambiguous way of writing the structural formula. So this is basically an ambiguous way of writing the structural formula. And B is also a molecular formula. This leaves us with the answer of A. A is not how do I say this? It's not a molecular formula because we can cancel all the wrong options and choose the correct answer. Okay, moving on to question number 8. Heating iron sulfide Fe2S in air produces sulfur dioxide. What is the maximum mass of sulfur dioxide produced from 120 kilograms of iron sulfide? Now notice they give you the mass in kilograms. So this has to be changed into grams, which is 120,000 grams. You might be wondering why we change it to grams. Well, this is because grams is the unit of mass in chemistry when you're calculating moles. Because the molar mass has the unit grams per mole, and therefore we have to make sure the units are same. So we have to firstly notice that we have to use 120,000 grams. And now we have to notice we have the stoichiometry between those two, because we are comparing FeS2 and SO2. So if you write the molar ratio is going to be 4:8. That simplifies to 1:2. So now we are given the mass. We can find the molar mass of iron sulfide by looking at the periodic table. You will be given that during the exam. So we can find the molar mass of FeS2. Now this is going to be 56, which is iron, times plus 32 times 2. Now this is going to give us 56 plus 32 times 2. This is going to give us 120 grams per mole. Now we know the formula. Mole is equal to mass over molar mass. This is going to give us 120,000 divided by 120. Now this gives us a mole of 1,000 moles. 1,000 moles. So we know that if there is 1,000 moles and the ratio is 1:2, then the mole of sulfur dioxide is going to be 2,000. You just multiply it by 2. So our first step of the process is done. Now we know that 200 moles of sulfur dioxide is going to be produced if there is 120 kilograms of iron sulfide. So now we remember mole is equal to mass over molar mass. So if we want to find the mass of sulfur dioxide produced, we can essentially just take this mole times the molar mass of sulfur dioxide. So molar mass, the mole we know is 2,000. The molar mass is basically sulfur plus oxygen. So sulfur is 32, oxygen is 16. 16 times 2 is 32. So this is going to be 2,000 times 64. This is going to give us an answer of 128,000. Now notice the unit is in grams. Now we have to turn it back into kilograms. This is going to give us 128 kg. And therefore the answer is going to be B. Question number 9. Which substance produces hydrogen and bromine when electrolyzed? So this is an electrolysis question. Which substance will produce hydrogen and bromine? Firstly, remember hydrogen is going to be produced H plus ion. Bromine is going to be Br minus ion. So we know that the positive the cation is going to be produced at the cathode, which is the negative electrode, and the negative the anion on the negative ion is going to produce at the positive electrode, which is the anode. So this is something that you have to know. Now secondly, we have to know that hydrogen is always produced if you use metals such as copper, if you use such as sodium. You cannot use copper because copper is below the reactivity series, and remember, as you go down the group, it is easier for the ions to discharge in case of the metals. So you have to know the reactivity series of the metals as well. So we cannot use copper, we can use sodium, and obviously bromine is going to get produced. This means we must have a bromide ion inside the ionic compound that we are going to be electrolyzing. So there should be a bromine ion, there should be a sodium ion, so there's going to be a competitiveness. H plus is going to be selectively discharged over the Na plus ion. Now for the negative ion or the N ion, bromine is going to get selectively discharged only when it is concentrated. Only when concentrated. If it's not concentrated, if the solution is not concentrated, essentially you won't get bromine gas, so we have to use concentrated aqueous sodium bromide, so B is the correct answer. Question number 10. Which statements about hydrogen fuel cells are correct? Water is formed as the only waste product. This is correct because remember the equation of the fuel cell, H2 plus O2 is going to give us H2O. Now we can balance this out to 2. Now see, you can see that the product is formed. Water is the only product that is formed. Both water and carbon dioxide are formed as a waste product. This is obviously not true because water, as you can see from the reaction, only water is produced. The overall reaction is 2H2 plus O2 plus 2 equal to H2O. This is correct. The overall reaction is endothermic. This is obviously wrong because remember hydrogen is basically burning in air. So this is obviously an exothermic reaction. This is an combustion reaction. Exothermic meaning heat is going to be released, it's not going to be absorbed. So 1 and 4 are the correct answer. So number 10, B is the correct answer. Question 11, ethane gas C2H4 is completely burned in excess oxygen to form carbon dioxide and water. This is a combustion reaction. The equation for the exothermic reaction is shown. Now they have already balanced it out for you. The table shows the bond energies involved in the reaction. Now what is the total change in the energy change in the reaction, or basically total energy change? Sometimes they will also call it enthalpy change. Enthalpy change. So you have to know the words that you're using is basically the same. Total energy change means the overall or the total enthalpy change of the reaction. Now obviously this is an exothermic reaction, they already mentioned it, so your delta H has to be your delta H value, or your enthalpy change or total energy change has to be a negative value because heat is being released. So basically we have to break the bonds first. Remember the equation, delta H is basically equal to bond breaking minus bond making. So breaking the bonds, we are going to break C2H4. The bond breaking is basically the reactants. The bond making is basically the product side of things. So product side of the equation, so we can basically solve it out. So C2H4 is ethene. We know that it's going to have a structure like this. Now we can visualize it as well. So we are going to have to break 4 bonds. So we're going to have to break a CC double bond. We have to break a CH, 4 CH bonds. So we can write it down like this. For CH bonds, we're going to break it, and we're going to break 1 C double bond C, right? And that is for the bond breaking. And for the bond making, we are going to minus it. The bond making, carbon dioxide is going to form and hydrogen is going to form. Oh, I forgot to add the oxygen. So basically you can see that there is an oxygen there, an oxygen here. So we have to actually and oxygen is basically O double bond O, O2. So because it is being multiplied by 3, we have to times it by 3. And then that is it for the bond breaking. And now for the bond making, so we have to look at the product side. In the product side, we can see that there is carbon dioxide, which has a display formula like this. So we are going to have to break CO bond to CO bond. And because it is this whole molecule is being multiplied by 2, we have to multiply it by 4. So it's going to be 4 CO bonds plus water is going to be formed. As you know, water is HOH, and this is the displayed formula. So we are going to have to break OH to OH bond in one water molecule. As we are breaking 2 water molecules, we have to break 4 OH bonds. 4 OH bonds. So if you take the values out, you have to be able to get an answer of negative 1313 kilojoules per mole. You can solve it out. Question number 12. Which rule describes the effect on the activation energy and frequency of particle collisions when the temperature of a chemical reaction is increased? So the effect of activation energy and frequency. Okay, so when the activation increases, energy increases, the frequency of collision will have no change. Now this is because you are not increasing the temperature, you are not increasing the pressure, so the collisions will not change. They will not gain kinetic energy. They won't hit more frequently, more effectively. The only reason why the active energy is raised or increased, this is done by the catalyst. So if you increase the activation energy, there is no change. So C is the correct answer. Question number 12. Which rules describes the effect of the activation energy and frequency of the particle collisions when the temperature of the chemical reaction is increased? When the temperature increases, the effective frequency of collisions will also increase. So this is because particles will gain more kinetic energy, they will hit each other, and they will hit the container more often and more effectively. This means the temperature rises, so the frequency of collisions will increase. However, the activation energy will not increase, or it will have no change. This is because activation energy depends on a catalyst. And catalyst's main job is to decrease the activation energy. Just because you increase temperature doesn't mean the activation energy is going to get lower or higher. So for this case, the answer is going to be B. Question number 13. Solid copper-2 sulfate exists in 2 different forms, anhydrous and hydrated. One of these forms is blue and the other is white. Remember, the hydrated crystal is going to be blue. The anhydrated crystal or anhydrous crystal is going to be white. This means water is not present in the crystal. The change between these two forms is reversible. What is the blue form and how is the change from blue form to white form brought about? So we know that blue form is the hydrated crystal and the white form is the anhydrous, or basically has no water of crystallization. There is no water that is chemically combined to the copper sulfate compound. So the blue form is going to be hydrated. It changes to a white form if you heat it up. The water is going to evaporate. It's going to break the bonds, the water that's being chemically combined. So D is the correct answer. Question 14. Sodium ions Na plus and oxygen ions combine with chromium ions to form a salt. The salt sodium dichromate has a formula Na2Cl2O7. What is the oxidation state of chromium in this salt? Okay, so we have to know the formula, basically the formula between these charges and ions. Sodium dichromate has a formula Na2Cr2O7. What is the oxidation state of chromium in this result? Remember, this whole salt, the oxidation has to be equal to 0 because it is a neutral and it is neutrally charged. So sodium has a positive 1, right? Sodium has a charge of +1. Oxygen has a charge of -2. So there's going to be 2 Na. So there's going to be +2 plus Cr, 2Cr, and then there's going to be 7, 2 minus. So because there's going to be 7 oxygen ions. So it's going to be 7 times -2. This is going to be equal to 0. So this is going to be 2 plus Cr minus 14. So Cr is going to be 14 minus 2. If we rearrange the equation, Cr is going to have a charge of +12. +12. However, this is for 2Cr, so we have to divide it by 2 again. So Cr is going to be +6. Okay, moving on to the next question. The concentration of hydrogen ions in 100 cm³ of 0.1 moles per cm³ hydrochloric acid is higher than the concentration of hydrogen ions in the same volume and same concentration, which is the ethanoic acid. Which statement explains the difference in the hydrogen ion concentration? Well, we know that ethanoic acid is a weak acid, hydrochloric acid is a strong acid. Okay, because ethanoic acid is partially dissociated, so CH3COH is going to be partially dissociated in water as CH3COO minus plus H plus ion. Now only 1%, around 1% is going to be dissolved or dissociated in this solution. So this explains why it is more weaker. 16. Which oxide is classified as amphoteric oxide? Amphoteric oxide, remember the definition, it can act as base or acid. So this could be aluminum oxide. Remember, there are only 2 types, aluminum oxide or zinc oxides. They are 2 examples that you have to remember for amphoteric oxide. Question 17. Which methods produce the salt copper-2 carbonate? Copper-2 carbonate is insoluble. You have to know your solubility rules. It is insoluble in water or in acid. So how are we going to prepare this insoluble salt? To prepare an insoluble salt, we have to prepare it by precipitation. So we have to basically, let's see the method which we are going to use. So we are going to, statement A says we are going to add copper-2 oxide to water and then add excess sodium carbonate. Then we are going to filter off the precipitate. Now this is not going to, so copper oxides are not soluble in water, right? So A cannot be used. Let's look at option B. Add copper-2 oxide to dilute sulfuric acid, then add excess aqueous sodium carbonate and filter off the precipitation. Now this method works because copper-2 oxide CO and sulfuric acid H2SO4 are going to react to give CuSO4, right, plus H2O. Copper sulfate is going to be produced and then another reaction takes place, which is the double displacement reaction. Copper sulfate, however, is a soluble salt. So when 2 soluble salts combine, we can create the insoluble salt, which is copper-2 carbonate. Now this happens because of a double displacement reaction. Now sodium carbonate. So the sodium is going to take copper place, right? And the copper is going to take sodium place, basically. So copper carbonate is going to form as a precipitate. So B is the correct answer. Question number 18. Which statements about trends across the period of the periodic table are correct? Aluminum is more metallic than sodium. Beryllium is more metallic than carbon. Boron is more metallic than lithium. Magnesium is more metallic than silicon. Now for this question, they are asking whether you really know the groups and the trends of each group. So number 1, this is obviously wrong because remember sodium, magnesium, aluminum. Now we are going, notice that we are going from the left side. In this period, we can see that as you move further from left to right, they get less metallic. Basically, they become less metallic characters, and they show more covalent characters. So, statement 1 is wrong. Beryllium is more metallic than carbon. Beryllium, remember, is Be. It is in group 4. And beryllium is in group 4. Sorry, it's in group 2. Sorry, that's a mistake on my part. It is a group 2 because it has 4 outer electrons. So it has 2.2 electronic configuration. It is in group 2. Carbon is a non-metal. Of course, beryllium is going to be more metallic. It is in the left side of periodic table. Statement 2 is correct. Boron is more metallic than lithium. Lithium is, we know, in group 1 metal. Boron is a group 3 metal. Yes. So basically, this means that as I've said, if you go from left to right, they become less metallic. And lithium is basically at the end of the left side of the periodic table. So this statement is wrong. Magnesium is more metallic than silicon. This is correct. Silicon is in group 4 like carbon. Magnesium is in the left side of the periodic table. Now this means statement 1, 2 and 4 are correct, so C is the correct answer. Question 19. Some information about the elements in group 2 of the periodic table is shown. The element and the time taken, to make hydrogen gas when it is added to cold water. When a metal is added to cold water, we see the density and the melting point. Which rows shows the correct trends? So trends in reactivity, density, melting point of the elements going down from group 2 of the periodic table. Now all these elements are group 2, notice about that. So we're going from top to bottom, we're going down the group. So essentially in group 2 as well, it is group 2 elements are basically similar to group 1 elements. They have similar trends as group 1 elements. So what this means is that you can see as you go down the group, the density increases. The melting point, however, decreases as you go down the group. Now, that is a property of group 1 as well. So if they are similar to group 1, we can see that their reactivity will also increase down the group. The density will also increase down the group. However, you can see that there is no clear trend because there is 185 at the top, and then the next one is 174, which is decreased, and then it is decreasing. However, at this when you get to strontium, the density once again increases again. So this means there is no clear trend in density, so we cannot say any trend. The melting point will decrease down the group generally, but if you look at the data that is being provided to you, you can see that there's decrease and then increase again and then it decrease again. So this shows there's fluctuations between the melting points. So there's no clear trend, so D is the correct answer. Question 20. A new element, oxfordium OX, was discovered with the following properties. Which group of the periodic table should the new element be placed? We know, so the solubility, it is insoluble in water, so this is most likely a non-metal. So it cannot be in the left side of the periodic table. Electric conduction, it does not conduct. All the more reason so that it could be a non-metal. This is proving it, OX, to be a non-metal. The formula of the element is OX2. OX2, now this is obviously a covalent molecule, is half the structure of a molecule. The bonding in the molecule of OX, so this is definitely is a triple bond. A triple bond means it has to be in group 5 or group V. This is because, remember, nitrogen, it also has a triple bond to each other, and it has 5 electrons on its outer shell, and 3 pairs of electrons are being shared between the molecules. Now this OX, oxfordium, is also similar to nitrogen, so we can say it is in group 5, so B is most likely the correct answer. Question 21, which rules describes a similarity and difference between chlorine and bromine? The similarity is that chlorine, right, they both are diatomic molecules. Diatomic molecules, right, because we write them as Cl2, Br2, I2. These are the halides or the halogens. The difference between them is that chlorine is more dense than bromine. This is wrong. Bromine is more dense than chlorine. As you go down the group, it gets more denser. So let's look at option number C. Both have atoms with 7 outer electron shells. They do have 7 outer shell electrons, and the difference between them is only bromine will react with aqueous sodium chloride. This is wrong. Obviously bromine, not only bromine, will react with sodium chloride. So both will react with aqueous potassium iodide. Yes, they will react because potassium iodide is a very good reducing agent. Right, so potassium iodide is basically a very good reducing agent. So it is going to be oxidized itself. Chlorine is more reactive than bromine. This is correct. As for one of the peculiar things about this group 7 elements are that when you go down the group, the reactivity decreases. So D is the correct answer. Question number 22, which statement describes transition elements? Transition elements are between group 3 and group 4. You can see in the periodic table, you can see this very big chunk. Now those are all transition elements. Now the general properties or trends of transition elements is that they have high densities and high melting points. So A is the correct answer. Question number 23. Which gas is made when powdered zinc is added to dilute hydrochloric acid? Zinc is a very reactive metal. It reacts with hydrochloric acid because it is above hydrogen in the reactivity series. Now it's going to react to give zinc chloride and hydrogen gas. So hydrogen gas is going to be produced, so C is correct. So 24. The diagram shows the structure of a solid. Which solid does the diagram represent? And this looks like an alloy, which is basically a mixture of metals. You see there are different size atoms. Now this clearly says that this is going to be an alloy. Now why is it not graphite? Well, graphite is made up of only carbon atoms. You can see there are 2 different size atoms. So it's clearly made up of more than 1 atoms. But you might be wondering why it's not sodium chloride, because sodium chloride has a regular packing arrangement, or a regular arrangement, a crystal lattice. It is in an orderly. It is alternatively sodium and chloride ions. So it's going to be Na plus, Cl minus, Na plus, Cl minus, and so forth. In this case, it's going to be brass. The other 2 are not. So B is the correct answer. Question 25. Steel is an alloy of iron. Which statement explains why steel is stronger than iron? Yeah, like I said, alloys are really made of more than 1 type of atom. So in the case of steel could be made out of iron. It could be added with carbon atoms. It could be added with manganese atoms, right? to make it more stronger. Now, this is because the carbon atoms in steel prevents the layer of iron atoms from sliding over each other. Because of the different size atoms, they prevent the layers from sliding each other. That's why it is harder. So D is the correct answer. Question 26. 3 students X, Y, and Z are told that solid P reacts with dilute acids, also conducts electricity. So this is most likely going to be a metal because it reacts with acids and also conduct electricity. The table shows the students' suggestion about the identity of P, which students are correct. Now remember, graphite is carbon, basically, and carbon does not react with acid that much. Copper, remember, copper is below hydrogen in the reactivity series, so copper cannot displace the hydrogen in the acid. So we have to cross it out. X is not an option. So it could be Y. Right? It could be Y. So the most reasonable answer for this question is going to be C. Right? Graphite is carbon. Carbon does not react with acid. Next, which statement explains why aluminum appears to be unreactive? This is because it is coated in an oxide layer, Al2O3. Aluminum is really reactive, so it reacts with the air around it. So this air around it will create a protective covering around it. So A is going to be the correct answer. Question 28. The electrolysis of aluminum oxide, the mass of the carbon anode changes. So the mass of the anode will change. Which rule describes the change and gives a reason for this change? Well, let's look at anode. Basically is the positive electrode in where the N ion, which is the negatively charged ions, are going to get selectively discharged. Now in the process of aluminum oxide, we have to look at the Al3 plus and O2 minus ions. Now this is being molten, so what is going to be created? So aluminum is going to be created and oxygen gas is going to be created. This oxygen gas is going to react with the carbon anode, thus forming carbon dioxide. Therefore, the anode part of the side, the mass of the anode is going to decrease as more times evolved. It will decrease because carbon reacts to form carbon dioxide. Therefore, A is the correct answer. Question 29. Several processes are used to treat domestic water. Which roles identify a reason for the given process? Chlorination is not to remove impurities, it is to remove bacteria or to kill harmful microorganisms. Filtration, we do it to remove insoluble solids. Now this is the correct reason, so B is the likely answer. Question 30. What is the equation for photosynthesis? Photosynthesis is basically an endothermic reaction. So in this case, the carbon dioxide and water are going to get absorbed by the plant, and then the plant is going to make food, which is glucose, C6H12O6, and it's going to produce oxygen as its waste product. Now we can balance it out. 6, just add 6 to everything. So it's going to be 6CO2, 6H2O, it's going to produce glucose plus oxygen, so B is the correct answer. Question 31. Which statement describes how the CH bonds in methane gas in the atmosphere contribute to global warming? Now CH bond in methane gas is single covalent bonds. Now how do they contribute to global warming? Well, this is because they will absorb the thermal energy from the earth and emit some of this energy back towards the earth. Basically, it reflects the energy back towards the earth and towards the atmosphere, basically. So D is the correct answer. You have to know how it works as well. This is a fairly new topic, I think, in the environmental chemistry. Question 32. Now this is an organic chemistry question. The structural formulae of 2 hydrocarbons are shown. Hydrocarbons meaning only carbon and hydrogen atoms. Which statement about the hydrocarbon is correct? So we can see that CH3, CH2, CH2, CH3 CH3, CH, CH3, CH3. So let's look at it. The first one is definitely going to be an alkane, because if we draw it out, it's going to be C, 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 C. It's going to be CH3, CH2, CH2, CH3. Now there's only single bonds here. This is an alkane. Let's draw the other one. CH3, CH, CH3. So this CH3 is going to be in the side chain, and CH3. The one with the bracket is going to be in the side chain. Mind you, the one in the bracket is going to be in the side chain. However, when you count all the carbon atoms again, you can see that they both have 4 carbon atoms. They both have the same number of hydrogen, right? They all are single covalent bond. They both are alkanes, and this means they are structural isomers, because the side chain is on the second carbon. So this is going to be C. 33. The structural formula of compound Q is given. What is compound Q? Okay, so this is looking like an ester. An ester is made when an acid, carboxylic acid, reacts with the alcohol, and it forms an ester bond, which has the formula COO. This R is basically a general, anything that can be attached to this C and O. So we can see there's a COO there. We are going to cut this formula after this second oxygen, COO. We are going to cut it out. So we can see that this side has 1, 2, 3, 4 carbon atoms. Now this is going to be, so we can say that it's going to be made of butanoic acid, and this butanoic acid forms the CH3, CH2, CH2, COO minus. This is going to form basically how do I say this? They're going to form the butanoate. And here the naming system is given here because there's 3 C's. So this is basically going to start with prop something, and this is going to be a propyl group. So it's going to be propyl butanoate. So C is the correct answer for 33. 34. The fractional distillation of petroleum is shown. Which fraction contains hydrocarbons with the longest chain length? The longest chain length is always going to be at the bottom of the because the lighter hydrocarbons are going to float. Lighters are going to float up, and the heavy ones are going to be at downstairs, obviously at the down of the fractionating column. So D is going to be the correct answer. Now, question number 5. Which equations represents the cracking of an alkane? Now this is basically, you just have to play it around with the equation a little bit. So, an alkane, if you crack an alkane, it could produce hydrogen. It will produce an alkene in the process as well. So, we can when we look at it, we can definitely cross out C, because C does not make sense at all. You cannot form a carbon and hydrogen basically like that. It does not separate it into different atoms, right? Let's look at A. A is not a cracking. It is basically the same thing, so we can cross A out. For B, we cannot add hydrogen to the alkane. This is definitely so useless. It's not possible. So the only cracking reaction is going to be D. So we can just add the carbon atoms together on the left hand side, on the right hand side. There's 6 carbon atoms in the left hand side, so that it should add into the same 6 carbon atoms in the right hand side. Question 36. What is the structure of the product of the reaction of propene with bromine? Propene is basically has a formula C3H6. Bromine is going to, because it is an alkene, is going to undergo addition reaction, in which the bromine is going to be added to the propene, and it's going to form a halogenal alkane. Now because CH, let's draw the structure so that you get an idea about this. So CH3, we can draw it C, CH, H, H, H. So there's going to be 6 hydrogen, and there's going to be a double bond. So the bromine atoms are going to go in the second atom and the first atom. So it's going to look something like this. So C is definitely looking like the correct answer. Question 37. In the reaction, 2000 molecules of CH2 react to form a single molecule X only. Which terms describe the reaction R and the CH2? Now this is basically an alkane. With this alkane is called ethane. It's going to react to form a single molecule only. Okay, so this is going to be an alkane, right? An alkane will only undergo addition reactions. Remember that, you have to learn it by heart. Addition reaction. Now this is going to be a polymer. Is going to form into a polymer. So 2000 molecules of the same monomer is going to form into X, which is a polymer. So this is going to be 37 is going to be A. Part of the structure of polymer is shown. Which statement about the polymer are correct? So here we can see there is a carbon amine, right? There is a amine group. Or we can just say this is called an amide linkage. In biology, we can say it also as the peptide bond. It basically means the same thing. Now this polymer is nylon because nylon has amide linkages. You have to know nylon is polyamide, right? Because it forms amide linkages. The polymer is formed by condensation polymerization. This is correct. Condensation polymerization means you remove a higher carbon. You remove a water molecule when you react the molecule together. There are ester linkages between the monomers. No, this is wrong. There are amide linkages between the monomers. So 1 and 2 is correct. So A is the correct answer. 39. The concentration of acids and alkalis can be determined by titration. Which pieces of equipment are needed to perform a titration? So to perform a titration, you definitely do not need a thermometer. You will definitely need a pipette. You will need the burette as well. So D is looking like the most correct answer. You don't need a syringe, right? You don't need a syringe at all. 40. Which chromatogram shows the R value of the substance that is calculated? The R value is basically how far the solvent moved, right? How far the solvent moved from the baseline. This is the baseline, right, to the end point. How far the solvent moved. Now this is the solvent, the baseline, and this is the solvent front. So basically in here, you can see that the solvent front has to be from here, from the baseline to the solvent front. So it should be from here, from the baseline to there. So B matches it. And the Y value should be here. It should not be from here to here because you can see that the chromatogram is not that. So B is the correct answer. So you have to know B is the answer because of the formula, right? R value is basically the distance that is traveled by the solvent. Distance that's being traveled by the substance is going to be divided by the distance traveled by the solvent. So this is going to be Y over X. Therefore, B is the correct answer. So we have reached to the end of the paper. Hope you understand every single thing. If you do not understand, you can please leave comments down below. I will be more than happy to provide more explanation and clarification if you need it. Anyways, thank you for watching. And again, see you next time. Bye.